We have periodic table, and this is a very interesting topic because it's very, very broad. Now, periodic table is a table that shows the arrangement of elements in order of increasing atomic number. Now, this is the first 20 elements of the periodic table. Now, the elements are arranged in order of increasing atomic number. This is atomic number 1, this is 2, this is 3, through 20. Now, one important thing you need to understand is that periodic table shows elements in groups. And it is very important for us to know the various groups a particular set of elements, metals, falls under, and a particular group non-metals falls under. Now, the metals, as classified here, majorly are the lithium, beryllium, sodium, magnesium, and aluminum. These are the metals. Now, why did I list out this? Because you will need it. When we get to bonding, when we talk about electrovalent bonding between metals and non-metals, most of the times they will not mention this element. They could just say which of these elements can form an ionic bond. Ionic bond is something as electrovalent bond, right? Now, apart from this, every other element can be considered a non-metal, right? Although boron can act as a semi-metal. Boron can act as a metal in some cases and can also act as a what? Non-metal in some cases. But it's very rare for boron, you hardly see boron, right? So metals are the ones I just listed out, and non-metals are these other ones. With the exception from this, these are the noble gases. They do not react, right? Because they are already stable. Their outermost shell configuration is stable, right? Okay. Now, lithium, beryllium, sodium, magnesium, aluminum, they all belong to metals. Group 1, Group 2, and Group 3 are mostly metals, with the exception of hydrogen, which, yes, it belongs to Group 1, but it's not a metal, right? Hydrogen is a non-metal, okay? Most of the times, they can give you an element to be X, and then they expect you to check whether this guy is a metal or non-metal, right? Now, for metals, the outermost shell electrons, right, will not exceed 3. Will not exceed what? Because metals are substances that give out electrons, did you know so? So if the electrons are less, it's very easy to give out. But if the electrons are more, it's difficult to give out. Instead, to do what? Accept. So for metals, or one of the properties, one of the characteristics of metals that you can actually look out for easily is that, note, their outermost shell usually don't exceed the outermost shell usually don't exceed 3. Now, this is for the first 20 elements, right? So most times, yesterday I taught us electronic configuration. So any element that has a valence electron 1, 2, or 3, they are what? Metals, right? Metals usually have valence electrons of 1, 2, and 3. Now, for non-metals, non-metals will always have 5, 4, and above, right? I'll say non-metals will always have valence of 4 and above. So why am I taking time to explain it? Because I'm heading somewhere. I want to, quickly talk about bonding before we actually look at those other parts. So metals, like I said, usually have valence electrons of 1, 2, and 3. Non-metals will always have valence electrons of 4 and what? Above. Remember I said that I don't want to treat chemical bonding as a different topic. So I've started periodic table. I want to quickly run through chemical bonding before I come back to the characteristics of periodic table, right? Ionic ties, atomic radius, and the rest of them. Now, why did I introduce chemical bonding? Because chemical bonding is basically the process where atoms come together, right, so as to attain a stable octet configuration. Is it not so? So I repeat, chemical bonding, which is also known as chemical combination, is a process in which atoms join together or combine together to form a more stable compound or molecule. Remember that the noble gases have a stable configuration. So every other atom looks forward to attain a stable configuration. So that is a major reason why they undergo bonding. If I am stable, there is no need for me to undergo bonding. So if I'm not stable, I will actually merge with some other person that is also not stable, so that both of us can attain bonding, right? So we have types of bonding. We have number one, we have electrovalent, which is also known as ionic bonding. Number two, we have covalent bonding. Number three, we have coordinate covalent bonding. Now the reason, like I said, the reason why I had to put up periodic table first is so that I'll tell us how the elements will bond, because periodic table and chemical bonding is almost 5 and 6. Chemical bonding is also known as chemical combination, and we have three major types. Electrovalent is also known as ionic. This covalent you're seeing here is also known as ordinary covalent. Then we have coordinate covalent. Now let's look at the first one. Now this, there are so many ways you can define electrovalent or ionic type of bonding, but then I made it to be very simple. I said it's a type of chemical bond that involves the transfer of electrons by a metallic what? Atoms, and the acceptance of the electrons by a what? A non-metallic atoms. Now let me show you something. If I have, let's say, sodium, remember I left this periodic table here so that anytime I say metals, you can always make reference to this. Is it not so? Now metals are, these are the metals, with the exception of boron and hydrogen. So when I say metals, let's say sodium. Sodium is this, and chlorine is this. Yeah, electronic configuration of sodium is 281, and this guy is 287. Remember I told us something earlier. You don't really have to start stressing yourself about electronic configuration. What is a pattern you're to follow? I told us that always look out for the valence electrons. Always look out for the what? Valence electrons is the electron on the outermost what? Shell. And in cases like this, I already taught us that yesterday. So make reference to the previous video yesterday. Now, this atom has three shells. The first shell has 2 electrons. The second one has how many? The last one has what? 1. This one, the last one has what? Now, by the number of the valence electrons, you can tell whether this guy is a metal or a what? A non-metal. That is basically the concept I wanted us to know. Remember I said metals, their valence electron is always 1, 2, or what? 3. Whereas non-metals is always 4 and above. So most times they may not even say N, they can say X. So just look out for the what? Valence electron. So for the fact that this guy has 1 valence electrons and this guy has how many? 7. It simply means that this one will be the one to give out the electrons, and this one will be the one to do what? Accept. So if this one should give out an electron, here becomes what? Plus. If this one should gain, here becomes what? Now listen, class, ionic bond or electrovalent bond is formed as a result of electrostatic attraction, right? If you have a plus and you have a minus, what do you think will happen? They will attract. Unlike charges do what? Attract. So in case somebody asks you which type of bond is formed as a result of electrostatic attraction or force of attraction, right? It is what? Electrovalent. Because if this guy should lose 1 electron, it will become what? Plus. This guy gains 1 electron, it becomes what? Minus and plus. And once you see minus and plus, they'll come together and form a very strong what? Bond. So I would have added that here, but there is no space. So in electrovalent bond, after the metal has donated electrons and non-metal accepts, the metal becomes positive charge, right? Non-metal becomes what? Negative charge. Because of the charges, they will now do what? Attract. So the bond is as a result of electrostatic what? Attraction. Now, any compound that is formed from electrovalent bond or ionic bond is called what? Ionic compound. So if I have Na plus this merging to form NaCl, this is ionic compound. Class, anytime you hear ionic compound simply means compound that can break as plus and minus, right? Because once you hear ionic, we have two types of ions, positive and what? So anytime you hear ionic compound, it means that it's a compound that one part is positive and the other part is what? Negative. So this is what we have here. And I said, note, the bonding usually involves what? Take note of that. Electrovalent bond or ionic bond always involves what? Metal and what? Non-metals. So why is this important? Because they can come here and say a bond between magnesium and oxygen is dash. So it's now left for you to recall, oh, magnesium is a metal, is it not so? Oxygen is a what? Non-metal. Because these ones here, this stuff I just enclosed here, they are all metals, right? Every other thing in this table can be considered non-metals, is it not so? So now, once you see magnesium is a metal, oxygen is a non-metal. So when you combine both of them, right, you're going to form ionic bond. Is it not so? So ionic bond involves metals and non-metals. Okay, now let's look at this. This part was what I really wanted us to know. Take note of this because most times students don't usually take note of parts like this. Characteristics of ionic compound. The first one is they have high melting and what? Boiling points. Number two, most ionic compound dissolves in water. That one is pure. The reason why it dissolves in water is because water is ionic in nature, right? Water is H2O, which can form H plus and what? OH minus. So imagine when you add something that can form, let's say if you add N plus, if you add something that can split into plus and minus, is it not so? Once it comes in contact with water, they will exchange. This N goes to this plus goes to this minus, and this one goes to this. They will mix up together, they will dissolve, right? So that is why if you add water to salt, it mixes up. Anything that can split into plus and minus, right? If you mix them together, they will mix. But anything that cannot split into plus and minus, if you mix it, it will not mix. That's why if you pour kerosene inside water, they will not mix. Because water can split as plus and minus, right? But kerosene cannot split as what? Plus and minus. Kerosene is an covalent compound. Covalent compound does not have plus, it does not have what? Minus. So that's it. Now the next one says, number 3, they mainly exist as solid at room temperature. Salt is an example, right? Solid as a room temperature, and they form a 3-dimensional crystal lattice. Now, so this covalent is something as ordinary covalent. We have coordinate covalent, we have ordinary covalent. It's a type of chemical bonding that involves the sharing of electrons between two non-metallic atoms. In the case of electrovalent bonding, two atoms, one is metal, will donate, the other one, a non-metal, will do what? Accept. But in covalent, both of them are sharing. You bring one, I bring one, we share. We are not donating. Compounds formed via covalent bonding is called covalent compounds or what? Molecular compounds. These stuffs are very, very important. An example of covalent compounds are, all organic compounds are covalent. Methane, butane, all of them are covalent because they involve two non-metallic atoms, right? Any compound that involves two non-metallic atoms, elements, they are covalent. We said usually it involves two non-metallic atoms. I already explained that. From the periodic table I gave us earlier, you saw it, right? Metallic atoms were the one are enclosed. Now, characteristics of covalent compounds. They are crystalline in nature like that of electrovalent. They have a definite shape. Their molecules are neutral. Remember, electrovalent molecules were not neutral, they were ionic. Plus and what? Minus. They are neutral and liquid. Most covalent compounds, they are liquid or what? Gases. Unlike electrovalents that we what? Solids. Now, obviously, if something is a solid, it will require higher melting or boiling point. Right? So since this one is already liquid, not just normal liquid, but what? I believe you know what is volatile liquids. Volatile liquids are liquids that evaporate easily. Their molecules are held by weak intermolecular forces. In the case of ionic bonding, their molecules were held by strong electrostatic what? Force. This one is weak intermolecular force, such as hydrogen bonding, Van der Waals. Have you heard of Van der Waals force? They have low melting point. This one is not new. They usually dissolve in non-polar. Electrovalent dissolve in polar. That is in water. Water is polar, right? But these ones do not dissolve in water because water is polar, but them they are what? Non-polar. Non-polar is something that they do not have dipoles. Dipoles means something that has a positive and a what? A negative. Electrovalent compound has positive and negative, right? That is why if you put it in water, it will dissolve. But these guys, they are non-polar. So they usually dissolve in non-polar solvents. Example of non-polar solvents are the organic solvents. Benzene, toluene. They do not conduct what? Electricity. It's very simple. Now we have coordinate covalent bonding. This is basically another type of covalent bonding. It's a type of covalent bonding in which the electrons shared by the two atoms is being donated by one of the atoms. A type of equivalent bonding in which the two electrons shared by the two atoms is donated by one of the atoms. Another name for coordinate covalent is dative bonding. So, example of this type of bond is mostly seen in formation of ammonium ion. In formation of oxonium ion. I'll show us why. Now, ammonium ion is basically when ammonia is reacted with H+. Now, H+, hydrogen is a non-metal. But hydrogen has atomic number of 1, is it not so? Anytime hydrogen has a plus, it means that it has lost one electron, is it not so? So the one electron that was present in hydrogen, if it loses that one electron, it becomes what? Plus. So that means the orbital of hydrogen is empty. If we have this is one electron here, right? But if this guy should lose this one electron, it becomes what? H+. So it means that there is nothing inside this box already. But meanwhile, in ammonia, nitrogen of this ammonia has a lone pair of electrons. Lone pair. Lone pair means non-bonding electrons. After forming ammonia, they realized that these two electrons did not take part in the bonding. Is it not so? So this guy is free. So what is going to happen here is that this would donate this electron. Since this one does not have any, we say, okay, no problem. I have two. Let's share. So this now becomes NH3. Most textbooks usually use something like this. H. To show that the electrons is coming from the nitrogen to this side, right? Now, when they now form together, there will now be a plus here. Why is a plus? That plus is coming from this H+, right? But the plus is basically attached to the nitrogen. Because nitrogen is very, very stable with 3 bonds. If nitrogen should hold 4 bonds, it will have a plus. Why? Because nitrogen was created to hold 3 bonds normally, right? But it has the capacity to hold 4. So, but if it holds 4, it is now excess. So once you see something is having plus, right? Plus in the case of a molecule, not an atom. In the case of an atom, means that something have lost electron, right? But in the case of a molecule, something that have more than 1 or 2, more than 2 atoms having a plus, it means that something in that compound is holding more than it's supposed to, right? But if an atom is having a plus, it means that that guy have lost electrons. Do you understand? If a compound has a plus, it means that that young person or anybody there is holding more than is supposed to hold. Is it not so? So in the case of this guy, in the case of H3O, this is basically water reacting with H plus. The same thing. Oxygen has a lone pair. So this comes to this, and we have H2O and H. So this now become oxonium. So this is ammonium ion. And this is oxonium or hydronium ion. Just in case somebody asks you and say, maybe in exams, you say, ammonium ion is formed from that type of bond. It's formed from which type of bond? Class, ammonia and ammonium ion. Listen. The type of bond that is formed in ammonia is covalent. Is what? Because nitrogen and hydrogen, they are sharing electrons. Is it not so? But the type of bond that leads to formation of ammonium ion is not covalent. Because in this covalent, we are bringing ammonia as a whole, right? To bond with what? Hydrogen. That process is the what? Coordinates, right? So the formation of ammonium ion is through coordinate covalent. The formation of hydronium ion is through what? Coordinate covalent. Now, another example of coordinate covalent bond is formation of complexes. Maybe you see something like Cu, NH3, see something like this. Have you seen something like this before? Now these are complexes. Now let me explain complexes. We call it metal complexes. In complexes, a metal, right, would be at the center, right? And then molecules will actually donate electrons for that metals. Like this compound you're seeing here, this guy will stay here. Now, this is how it works. What we have here inside the bracket is called a what? A ligand or ligands. Ligands or ligands are molecules that can donate electron pair. They are not donating single electrons. Electron pair is how many electrons? 2. Right? Remember in coordinate covalent bond, 2 persons are sharing electrons, but it is 1 person that is donating the entire 2 for sharing, right? We saw that in the case of this. Another example is in complex. The only difference between complexes is that in complexes, the central atom is a metal, right? And what is donating the electrons most of the times is not just a single atom, it's always a whole molecule. Ammonia is not an atom. Ammonia as a whole is the one donating. I just want to explain this. Hydrogen bonding is not a type of a chemical bond, it's a different type of bond. Class, as the name implies, please put down. Hydrogen bonding is the bond between hydrogen and a highly electronegative atom. Bond between hydrogen, bond between hydrogen and a highly electronegative atom. Now, it's not all the times that hydrogen bonds to any atom that is hydrogen bonding. No. Electronegativity is basically ability of an atom to attract electron to itself. So, for example, if hydrogen bonds to fluorine, fluorine is highly electronegative atom. This is hydrogen bonding. Hydrogen bonds to oxygen. This is hydrogen bonding. Hydrogen bonds to nitrogen. This is hydrogen bonding.